See the problem number 5. A circle of diameter 50 mm rolls along a straight line without slipping. Draw the cycloidal curve traced out by a point P on the circumference for one complete revolution of the circle. Okay. So suppose this is a circle. On this circle a point. Okay. And if this circle, it will be go this side straight way and also rotate. Its own rotating. So what will happen? It will be rotating in this portion. Means there will be rotation, erosion, translation curve. Means the circle will be rotating as well as translation from this position to the up to the complete revolution. Okay. So what will happen? Up to a certain position, the circle position will be like this. After a certain position, the circle position will be here. After a certain position, circle will be here. After a certain position, circle position here in this way. So each position P, suppose here P, so it will be rotating. Suppose here this will be the point P. Then here this will be the point P. In this circle, this is the point P. Here and here this is the point P. Now this is the point P. So in this, if we join this P, different position of the point P, and we get this type of curve. This curve is called cycloidal curve. Cycloidal curve. Clear? So now how to draw? Okay. So here it is given the circle diameter 50 mm. So first we draw a circle of 50 mm diameter. Okay. On this circle, first draw the center line. Okay. Now we consider this point. This point will be the P. Clear? Now at this point, here we draw a line, draw a horizontal line of dimension pi into d. Dimension pi into d. Clear? Now and the pi into d is comes as 157.07. The value of the pi into d, the value of pi into d has comes 157.079 millimeter. If we calculate, you get it. And we take is 157 millimeter. So from point P, we draw a horizontal line. The distance will be 157 millimeter. Okay. First, we divide the circle by 12 equal parts. Now, the total angle of the circle is 360 degree. So if we divide 12 equal parts, it will be get each angle will be 30 degree. So here we draw a line 30 degree. Here also draw a line 30 degree. And another draw 60 degree. So by protector or by 30-60 set square, you can get it. So means this angle and this angle will be the 30 degree. this angle and this angle also 60 degree, this angle also 60 degree, and this angle also 60 degree. Clear? And give the name in this way. So this is 1, this is 2, this is 3, this is 4, this is 5, 5, this is 6, this is 7, 8, 9, 10, 11, and 12 will be the P point. Okay. Now what we will do? First we each point we draw the horizontal line. So first, and you see 11 and 1 will be in same line. Then 10 and 2 will be same line. Then 8 and 4 will be in same line. And 3 and 9 will also be in same line. And 7 and 5 will be in same line. And 6 will be on same line. Okay. So each point you have to draw the horizontal line. Here 11 1 in same line, 10 and 2 in same line, and 8 and 4 will be in same line, 7 and 5 will be the same line, and 6 also in same line. Okay. Here some it is not draw in direct by dimension, so some gap will be there. It must be correct. Okay. So first what we'll do, we divide this horizontal line in 12 equal parts. So this is not possible in by scale because this is 157 millimeter. So 157 over 12 it is not possible by scale. So we apply the general method. So how can we apply the general method? So first we draw a line less than 90 degree. Any length of the line less than 90 degree. Okay. And it is 12 equal. If you divide the circle 12 equal parts, you divide this pi d line also in 12 equal parts. Okay. So if we write this is P and this is P dash, so this is also P dash equals to pi d. So first, how can you divide? So first, draw a line less than 90 degree, and by taking any measurement by compass, divide PP dash in 12 equal parts. So we draw a line on this P point less than 90 degree, any length of the line. And if you divide 12 equal parts, so first take any measurement by compass from the point P, and we divide it. 3, 4, 5, 6, 7, 8, 9, 10. So then give the name 1, 2, 3, 4, and 10, 11, and 12. 5, 6, 7, 8, 9, 10, 11, 12. So first we join last point with this last point. First we join this. Clear? Now you have to draw the parallel line by, already in first class we discussed about the how to draw the parallel line by using the two set square. So by using the two set square, first one set square fixed with this line and another set square hold it, then again in this way you can draw the parallel line. If you see the note for the first class, you can find out how can you draw the parallel line by two set square. So first join 12 point with this P dash, then at this point join a line parallel to this. Next join parallel to this. Clear? Here it is because if you choose the compass, you see this gap all are remains same. Okay. Here it is not drawing in according to the dimensions, so the gap will be not uniform. So basically the method will be, first you draw any line less than 90 degree and divide it any where it is required 12 equal parts. So by taking any measurement by compass and divide this line 12 equal parts, last point to last point join. Okay, then draw the parallel line on each point, suppose 11, 10, 9, 1 and up to the 1, and here you give the name. This is 1, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now each point from 1, this is your center line basically. 9 and 3 will be the center line, this line. Okay. So each point you have to draw lightly a vertical line up to this center line. Similarly from 2, another. If you actual figure these two line may be inside also. This is not, means when you draw the actual according to the dimension, your 2 point when you draw a vertical, it may be inside the circle. This is not the problem. 3, then 4, then 5, 6, then 7. Just you have to draw the perpendicular line of this line in each point. And you give the name. This is C1, this is C2, this is C3, this is C4, this is C5, this is C6, this is C7, C8, C9, C10, C11 and C12. Basically these are the, in this line when the circle will be go in this right direction, so this is the different center point position. Yeah. Now take this radius from this center point, take this radius, first center point C1 And what will be the cut at one horizontal line? Suppose it will be cut here. Then center point, you take this radius, means your radius will be the 25 millimeter. So take this radius, center point C1. C1 means in horizontal one line, what will be cut? It will be cut it here. Then center point C2, where it will be the cut? Suppose it will be cut it here. Then C3, this is the 3 horizontal line. Suppose it will be cut it here. Then 4, C4 center point, then cut it here. C5, cut it here. Then C6, it will be just touch. You see, there will be just touch. Then C7, again, this is the 7 horizontal line, this line. Then C8, this is the 8 horizontal line. Then C9, again 9 horizontal line. So in this line. Then 10, if you put the C10, it will be cut it suppose here. At C11, again 11 horizontal line, and 12 will be at this point, it will be master unit. So if we join the curve, so the curve will be like this. The curve will be like this. So this is the cycloidal curve, and this curve must be dark. So we go to the next problem. A coir unwound from a drum of 30 meter diameter. Draw the locus of the free end of the coir or unwinding through an angle twice pi radian. Okay. Now, basically, if you see, suppose there will be a drum. On this drum, there will be a coir wound. Inside this drum, there will be coir wound. Okay, and you see the there will be an unwound part of the coir. Okay, or wire. So, if you rotate it twice pi radiation, what will be the position of this unwound part? If we join this, we get the curve. This is called basically that you have to draw this here. Okay. So all of you see the CSC electric wire. It will be drum. It will be drum type things on which the wire will be the wounded. Okay. So so in the last point, you see there will be an unwound part. So if we rotate this twice pi radian, so what will be the position of this unwound part? If we join this, we got this. Okay. So for this, what we will do? So first we similar here the circle diameter is given 30 millimeter. So first we draw a circle of 30 millimeter diameter. Okay, and draw the center line. And if we consider, here the point. Okay. So same way here, pi d equals to you come. If you calculate this, pi d comes as 94.24. 94.24 millimeter. And it will become considered, we take is 94 millimeter. So at point P, we draw a line, draw a horizontal line. At point P, we draw a horizontal line of 94 millimeter. Okay. And here we divide the circle 8 equal parts. So if we divide the circle 8 equal parts, so each angle will be the 45 degree. So you divide the circle 8 equal parts. So we draw the line, means angle will be 45 degrees. So by using the 45 degree set square, we divide the circle 8 equal parts. So this will be the 1, 2, 3, 4, 5, 6, 7, and 8 will be the P. Now, here we draw a line. This is in pi d, and if you divide the circle 8 equal parts, means if you divide the circle x equal parts, you divide this pi d line also x equal parts. So here we divide the circle 8 equal parts. So we also divide this 8 equal parts. But similar way, this is 94 millimeters. So by scale we do not get it. So for this, what we'll do, we divide it, we draw a line, and by take any measurement by compass. And give the name 1, 2. So first, same way, we join last point with this last point and draw the parallel line similar to previous one. And give the name 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now each point, that is 1, P already 1, 2, 3, 4, 5, 6, 7, 8. Each point we draw the tangent, and here already at P point we draw the tangent. So how can you draw the tangent? Suppose at 1. Suppose this is 45 degree. Now here if we draw with the horizon 2, 6 line, with the horizontal line another 45 degree, then we get the tangent. So here we draw the tangent. Similarly 2, this is perfectly 90 degree, and 3 is another 40 using the 45 degree, and then 4 is the again 90 degree horizontal line. Then at 5 again using the 45 degree with the horizontal, if we draw a 45 degree line, we get the perfectly 90 degree. Then 6, this is the horizontal line, vertical line, and at 7 again 45 degree we draw this. And remember thing, first 1, 2, 3, 4, your length will be the tangent will be must be more. Means the length at what you draw at 1, the 2 will be must be more, 3 will be again more, 4 will be previously more. Because now what we'll do, first we by compass measurement P with 1. P with 1 means 1 to P. So by compass, if we draw, so this will be suppose here, cut it. We cut it here. Okay. Then P with 2, from the 2 tangent line, you just draw the arc. Very means when you draw the arc at first you by compass measurement P with 2 at 2 point at the tip of the compass, and you draw a arc. Then P with 3 at 3 point we draw another arc. Okay. Then P with 4, if you measurement that 4 point, you tip of the compass will be 4, and it will draw another arc. Then P with 5, this is the radius, take the 5 point compass, it will be take like this. Then P with 6, this will be like this. Then P with 7, in this way it will be curve will be like this. So from this point starting, it will be like this. So this is the curve for the locus of the unwound wire. Now problem number 7. Construct an Archimedean spiral of 1.5 convolution having the greatest and shortest radii are 90 mm and 30 mm respectively. So there will be two radius. One is 90 mm, one is 30 mm. So first we take a large circle by using the radius 90 mm. And same concentric circle we have to draw using 30 mm radius. So first we by using 30 mm radius, okay. So by first we draw a 90 mm radius circle and we draw a 30 mm radius circle. Clear? Now here you have to see there will be a 1.5 convolution. Means suppose if we write, so this is the O, this is the A point, and this is the B point. Now A with A go in this direction from the A point. Basically this point A, in this direction it will go, and also it will be rotate. What will be the rotation? One full rotation, then half rotation. Then what will be the position of the point A? Or it will be from A point or from B. B also from B to A, it will be go in this direction, and it will be also rotate. First 1.5 convolution is given, so one full rotation, again half convolution, half rotation. So for this, what we'll do? First we divide the circle 8 equal parts. Okay. First we divide the circle 8 equal parts. Yeah. And give the numbering such way that suppose if we start from this, this is 1, 2, 3, 4, 5, 6, 7, this is 8. Again half convolution, so this is 9, 10, 11, 12. Because it is 1.5 convolution is given, so one full rotation, then again half rotation. Yeah, means after A, it will be come at here. It must be here. This B position will be here. Means A, when A go to the A from A to point B, then the position of the point A, it will be go this direction as well as it will be rotating in this direction. So last position will be at this point. Yeah. Now we know OA equals to 30, OB equals to 90. So AB equals to 60 millimeter. Now it is given 1.5 convolution. So we divide 8 equal parts of the circle. So we divide the AB 8 into 1.5. So this will be the 12. Okay. So we divide the AB 12 equal parts. So this is 60 millimeter AB. So AB if we divide 12, it will be 5 millimeter. So this is This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This P point also 12. Okay. Now take the radius O1. Take the radius O1. It by compass it will be cut here. Take the radius O2. It will be cut it here at 2 line. Take the radius O3 at O3 line. It will be cut it here. Take the radius O4. It will be cut it here. Take the radius O5 from O5 line from the center point O. It will be cut it here. Take the center point O, radius O6. It will be cut it here. O7. This will be O8. 8 will be this point. Then 9. Then again 10. Then 11. Then 12 will be this point. So when we join the line, it will be like this from starting from the point A. So starting from the point A, so this is the cycloidal curve, Archimedean spiral curve, not cycloidal, Archimedean spiral curve. So this is the Archimedean spiral curve.